Why does the moment you try to learn which slit it used, the beautiful fringes fade into a bland blob? In the energy filament theory, a measurement is not a magical readout that leaves reality untouched. It is a coupling that forces the two roots to leave distinguishable marks in the energy sea. And that physical rewrite breaks the shared sea state that made interference possible. The mainstream slogan is "observation collapses the wave function." And people argued for decades about whether consciousness matters. But you don't need mysticism to lose interference, you only need plumbing. Put a detector beside one slit and you've effectively driven a stake into one shipping lane. A stake is information, but it is also an obstacle. It changes local texture. It reshapes the tiny current lines. And it can tear the phase relationship that used to keep two roots in step. And here's the hard requirement. If you truly gain path information, you've made the two canal states distinguishable. That means the sea can no longer treat them as one superposable map. It must carry two separate ledgers to different, this is what happened, imprints in the environment. Once the ledgers are separated, the interference term dies, because cancellation requires a shared phase reference. If the two roots don't share one phase bookings, then peak meets trough cannot reliably mean canceling. It just means two unrelated stories happen to overlap. So what remains is just root A probability plus root B probability. Which is exactly why the screen turns into a two-hump envelope instead of fine stripes. This is not philosophy, it is engineering trade-off. The sharper you want the path label to be, the stronger the coupling must be. The stronger the coupling, the more you deform the sea state that was doing the delicate cancellation work. It's like trying to measure the ripple pattern on a pond by sticking a measuring stick into the water. The more firmly you held the stick, the more the ripples you cared about got scrambled. This is also why the old classroom line "you must shine light to see the electrons" points in the right direction. Any reliable tag requires interaction, and interaction is a rewrite. And that's why weak tagging only partially washes out fringes. You didn't fully separate the ledgers, so some coherence survives. Now, what about the famous quantum eraser? It's often told as if you could erase the past and bring the fringes back by changing your mind later. A cleaner way to say it is, you didn't destroy all structures. You moved it into correlations. If you record which path tags, then later mix, rotate, or sort your data by tag rules that restore a common grouping so that within each subgroup the two roots are again treated as equivalent, you can recover fringe-like patterns inside those sub-ensembles. You didn't rewind time, you changed the bookkeeping lens through which you project the sea state onto statistics. Interference is not simply present or absent. It is presented under which grouping rules. Because grouping rules decide whether the two roots are treated as one coherent map or two separate ledgers. That's also why none of this lets you send signals faster than light. You only see the recovered fringes after you compare and sort the records. And the raw local dots stay random. Here's a human scale analogy. Feed the metronome click only into your left ear, and suddenly you can tell where the beat came from. But you also split the band's timing experience into two channels. The shared phase feeling that made the groove effortless is no longer the same. Information is not free. Every extra bit you demand must be paid for by extra structures in the sea. And that structure pushes back on the very pattern you hope to read. Next episode, we'll step into entanglement and ask what happens when two distant detectors are effectively reading one shared sea ledger. Tap follow, share it on New Physics, Clear Universe.